different types of line we have to has to be used for preparing the proper drawings. The first and foremost, the most important type is A and B type line. This is continuous thick line, single stroke drawn. It is used for drawing visible edges. So here you see this is the outline of the figure, so that can be a little thick. So A type line, continuous thick line. Now B type line, continuous thin, projection lines, hatching line, dimension line. So all those things are used drawing thin lines. Now this is C type line, continuous thin, curved, partial or interrupted views. That means this is a broken object. So in order to indicate that this is a broken object, or this interrupted view can be drawn using C type line, that is continuous thin. Only thing is that it is curved. Now D type line. D type line is continuous thin zigzag, partial or interrupted views. So for a sheet like this, not to be sure that it's only partial, it extends further. To indicate that, we will be using D type line. And now E type line is dashed thick, hidden outlines. So here we have an object like this. If we draw the orthographic view of that one, the certain things here, that edge is hidden if you look from the front, so that can be marked dashed thick. It forms the outline, that is why it is thick. And the other one, this one, from here an edge is there, that is marked using F type line, dashed thin. F type is dashed thin. We also say dotted line. Now G type line, chain thin, is also called center line. Center line, axis of symmetry. So in the case of shaft, etc., we will be using that one. And then H type line, chain thick with thick edges. So this is thickened. So actually G type line thickened at ends, that is H type line, to show that cutting sections. So here you may see this is actually I type line. A new section is formed, an object is cut in this way, so the cutting plane changes direction, that is I type line. Another form of H type line is I type line, where cutting plane is used to indicate the cutting plane. J type line is chain thick for some application. This indicates that some surface treatment or something is done. So this surface is treated or thermally treated or electroplated or something. So in order to show that, we will be using J type line, thick chain surface, which requires special treatments like polishing, hardening, etc. And this is chain thin double dashed, extreme positions of movable parts. So this is a movable part. Originally it is here, now it can move up to this angle. So that extreme position, to show that one, we have used this K type line, chain thin double dashed, and path is shown using a G line, that is center line. And this is hatching line. Always this hatching line is drawn almost 45 degree to the axis. The hatching line shall be equally spaced, and the spacing depends upon the size of the figure. Right, today now we will discuss elements of dimensioning. The elements are projection line, dimension line termination, and dimension. If you refer a figure, we want to dimension this feature. This is 150 mm long. This is the projection line. These two parallel lines, this one and this one, are projection line. Or else this is projection line, this is again projection line. The line which extends from the feature to be dimensioned is called projection line, and this line and this one, these are called a dimension line, and this numerical value is called dimension. This is dimension line termination, the arrowhead. So these are the four features: dimensional, projection line, dimension line termination, arrowhead, then numerical value, which is the dimension line. All these projection line, dimension line, etc. are marked using thin line. The rule for drawing an arrowhead is like this. If the width of the arrowhead is x, its length shall be 3x. From here to here it is 3x. From here to here, this is the width of the arrowhead. That is x. The length shall be 3 times the width of the arrowhead. Different methods of arrowheads are there. The dimension line, etc. can be terminated by different ends. This is cross-filled arrowhead, crossed blank arrowhead, open arrowhead, oblique stroke, dot, etc. But maybe this may be better. Let us quickly check the different ways of dimensioning a circle. Here the phi indicates it's the diameter. It's a 40 mm diameter circle. We have, through the center, we have drawn a dimension line, and the dimension line ends with the dimension line termination arrowheads, and the numerical value is written here. Still a smaller value. Diameter is 20, and since there is no sufficient space, the dimension line is extended outward and the dimension value is entered. Here again the diameter is 20. Instead of writing inside, arrow is pointing towards the circle from both directions, and it extends and forms a leader line. Here 520 is marked. This is a very small diameter circle, so just a single line at an inclination 45 degree or so. 510 is marked. Dimension can be marked outside also. 540 is marked like this way. 532 this way also possible. It will pass through the center. Okay, these are the different ways how the dimensioning of a circle is done. Curves of a figure are marked R5, R20, R20. These are the different ways. The curvature of a 2D figure is marked. Curvature of a 2D figure is marked. This is the 3D figure. This is the 2D figure. So the square symbol indicates that this is a square, and this is the spherical object. Spherical radius is 20. It is marked. SR symbol shows that it is spherical. Spherical diameter is marked. This is a small disc with a projection. So if the dimensional value is very small, if sufficient space is not there, it can be marked in different ways. So different methods are shown. Now let us learn common dimensioning errors. certain things are correct, certain things are wrong. So in a single figure, at a single place, correct method and incorrect methods are shown. See, this is the front view of an object. This is 50 mm width, the rectangle portion with a center hole. This is the side view. Left side view is drawn on the right hand side. And this is again front view and side view. So this is 50 mm. Naturally this is 50 mm. So both should not be simultaneously, need not be represented simultaneously. So this is the correct way. Only in the more clear picture it is represented. The other thing is that, the second thing is that we can dimension it in the front view or in the side view. The side view is having some dotted lines, etc. It is not that clear. So the dimension shall be placed in the more clear picture. This front view shows a more clear picture. Now dimensional value has to be written. This is dimensional value, this is the dimension line, and this is the projection lines. The dimension line, as far as possible, it shall be outside the figure. Here it is represented inside, that is wrong. So right hand side, this is always right hand side is incorrect. So dimension line and dimensional value shall be placed outside as far as possible. This is another method. Here in the side view, in the front view, this 25 is represented here, but this dimension line is very close to the feature that you are dimensioning. So it shall be approximately 8 mm away, or it can even be 10 millimeter away. So this is a better way. It is placed in a better way. Now dimensions are marked on visible lines. See, here the dimension is marked inside in a hidden dotted line. So the dimension, that is wrong. The dimension shall be marked outside. So then an L-shaped figure. So here 150 are marked. See, this is the right way. Why this is wrong? Because two dimension lines cross here. As far as possible, crossing or dimension line shall be avoided. So here an object may be it's a rectangular object with the two holes, and this is the right way of dimensioning the gap between centers of, or the distance between centers of two holes. Never the center line or the should be used for dimensioning. This is wrong. This is correct. Then this is 80 mm width and 145 mm length. That is correct. But here what is marked is this is 80 mm and this is 1.45. Maybe that is meter. So this is 80 mm. This is 145 mm. So if it is 80 centimeter, it shall be 145 centimeter. If it is 80 mm, it shall be 145 mm. So both shall be same unit. Now projection lines should not be drawn with a gap. This gap is not permissible. The projection line, this is projection line, this is projection line. It should start from the feature it is to be dimensioned, and this projection line shall be perpendicular to the feature to be dimensioned. This is the feature to be dimensioned, and projection line shall start from the feature to be dimensioned and shall be at an angle 90 degree with the dimension line. This is again a wrong way. So this is the projection line, this is the dimension line. Those two lines cross. Here the crossing is avoided. Here we have the dimension 80 mm marked. So here at an angle it is marked. That is not possible. That is not permissible. because this is projection line, this is projection line, projection shall be at an angle 90 degree to the feature dimension. Now here 20 degree 20 mm, there is no sufficient space, so this way we can represent, but it shall be at an angle greater than 30 degree. Here the angle is very less, so the leader line shall be at an angle greater than 30 degree. So this is a broken feature. Again, the dimension need not be broken, dimension line need not be broken. Here dimension line is broken, that is wrong. So this width is, this gap is 35 mm, shall be taken outside and drawn. Inside we shall not draw. Now this is 53 degree, it should not be inside, this is wrong and this is correct. This is hatching line, this is correct, that line shall be slightly rubbed off and without rubbing off over the hatching line we shall not draw the numerical value. These are the some usually occurring mistakes while we dimension things. Arrangements of dimensioning. Actually, there are 4 different types of arrangements of dimensioning. The first one is chain dimensioning. Suppose we have a component like this. Suppose it is a cylindrical, stepped cylindrical part. If the dimension of this part is, length of this part is 50, it will be marked separately 50. Then the next part, if it is 30, the dimension of that one will be marked separately. Then the last part, the end part, again that will be, if it is 20, we will mark 20. This is chain. Now second one is parallel dimensioning. Here the dimension is being with respect to a common datum, so this edge may act as a common datum. So the first part is 50 mm, so that is marked here. Then second part, the end of second part from this common datum, it is 50 plus 30, 80 mm away. And for the last part from the common datum, it is 100. So from the common datum it is 100 mm away. Third one is combined dimensioning. It's a combined dimensioning. So here both the chain dimensioning and combined dimensioning, parallel dimensions are combined in one drawing. So this is 50, and if you apply parallel dimensioning from here to here, it is of course 80. And now we apply chain dimensioning for the last part. So this is 20. This is 20. This is how it comes. From here to here it is 50. From here to here it is 80. The last part alone is 20 mm. This is combined dimensioning. The last type is superimposed running dimensions. Running dimensioning. Here we put a beginning, a starting point. This is the starting point. Then serially, just like parallel dimensioning, we mark this is 50 mm. Usually we mark dimension at the center of the dimension line, but here we don't use two arrowheads, only single direction arrow is used, and here it is from the starting it is 80 mm away, so 80. Now we will discuss systems of dimensioning. There are two systems of dimensioning. The first one is aligned system of dimensioning. We will have to dimension both linear as well as angular dimensioning. The reference figure for dimensioning any linear feature is this one. See, if it is a horizontal one, we will dimension like this. If it's an inclined one sloping rightward, the numerical value will be written in this fashion. But it is inclined downward means this will be dimensioned in this fashion. Vertical dimensions will be readable from the right. So if you want to dimension this one, this is a vertical dimension, vertical feature. So it shall be readable from a person looking from here, from the right side. So it's again a horizontal dimension. Dimension is written over the dimension line at the middle without touching the dimension line. Now this is an inclined dimension, inclined feature, a sloping feature. It is dimensioned this way. This also can be dimensioned this way, but this is sloping downward. It shall be dimensioned in this fashion. The thing is that it has to be dimensioned neatly, that you have to take care of. In the case of angular dimension, the reference figure is this one. These dimension lines are curved dimension lines. So there's a curve is there, the curved lines. And the dimensional value is written at the middle of the dimension line, over the dimension line, without touching the dimension line. And the numerical value it conforms to the curve of the line. It can be considered as a convex line, and this can be considered as a concave line. Here also dimensional value is written over the dimension line without touching the dimension line and at the middle of the dimension line, and it conforms to the slope or the form of the numerical value conforms to the curve of the line. Now it has been shown like this. We want to dimension this angle 45 degree. We have used a convex line. 45 degree is written over that one. It's a concave line. 45 degree is written over that dimension line. Here, whenever we want to dimension angles, we will be using curved dimension lines. Another way, written over the dimension line. Here also written over the dimension line. So this is how we do the dimensioning both in aligned system. Another system is unidirectional system. Unidirectional system. So the reference figure for linear dimensioning. Whenever we want to dimension linear system, the reference figure is that unidirection means direction of writing the dimensional or numerical value. See, all the numerical value is written in a single direction. It can be readable from the bottom. But the thing is that horizontal dimension, for horizontal dimension, the dimension line is not broken. In all other cases, the dimension line is broken at the middle and the numerical value is written vertically. So this is how we represent the horizontal dimension. This is the horizontal dimension. Without breaking the dimension, we have written. But in the case of a vertical dimension, the dimension line is broken here and numerical value 40 is marked here. And in the case of sloping line, the dimension line again it is broken at the middle, but the numerical value has to be written vertically. Then here also dimension line is broken and numerical value is written vertically, so that from the bottom it can be read. And now in the case of angular dimensions also, the dimensions lines are broken. Here I have forgot to break the line, so a wrong mark is given there. Now see, the line is broken and 45 degrees indicated vertically. Again vertically unidirectional, single direction, 40 degree, 30 degree, 30 degree. Everywhere dimension line is broken. So we have two systems of dimensioning. One is the aligned system of dimensioning and the other is unidirectional system.